Hello everyone, welcome to Lim channel. Today I will discuss with paper 1 pure math 1 with the code 970912 May June 2011. I hope this channel can help with your exam. And let us start for the first question. The first question, find integration x to the power of cube plus 1 over x to the power of cube. So for this one, I will make this 1 over x to the power of cube become the indices first. This x to the power of cube plus x to the power minus 3 dx. This x to the power of cube, we have to add 1 power. So it becomes x to the power of 4. And then we divide it by 4. The new power is 1. And then plus with this x to the power minus 3, we plus it with 1. So we got x to the power minus 2 over minus 2, the new power. And then plus c. So at the end, it will become x to the power 4 over 4 minus x to the power minus 2 over 2 plus c. That is for number 1. For number 2, find the term in x squared and x to the power 3 in expansion 1 minus 3 over 2x to the power 6. So we remember again that the formula of the combination of the binomial expansion a plus b above n equals to ncr a to the power r times b to the power n minus r. So this, the n, obviously it is 6. Okay, 6 combination. A is 1. And then the b is minus 3 over 2x. Minus 3 over 2x. And then we want to get x squared, of course. Here, we focus on this one, which has the x. So this x to the power of 2, so this should be power of 2. And then this is 6 minus 2, or let's say it is 4. So we have 6 combination 4 times 9 over 4 x squared. So for this, if we calculate with the combination, we shall get 135 over 4 x squared. That is for the x squared. And for the x to the power of 3, so 6 combination, and then this is 1 times minus 3 over 2x. We want to get x to the power of 3. Of course, this is the power of 3. This is the power of 3, and then this is the power of 3. So we have 6 combination 3 times, this is minus 27 over 8 x to the power of 3. If I calculate with the combination, I shall get minus 540 over 8 x to the power of 3. That's for the first part. For the second part, it say it does not want to have the term of x to the power of 3 in expansion this. So the k must be how much? In the value of constant k. So we have already this. This I delete this first, then so later this k we have to make become x to the power of 3. So we can know that there will be no x to the power of 3. So this k later will times with this one. And this 2x become x to the power of 3, it have to times with this one, 135 over 4x squared. Okay, so if I want to arrange it, it will become k plus 2x times minus 540 over 8x cubed plus with 135 over 4 x squared. So k times with this one and then 2x times with this one. So I have minus 540 over 8 k x to the power of 3 plus with, and then this 135 over 2 x to the power of cube. So this k must be how much? So if you want to get no term in x to the power of 3, so of course it's minus 50 over 8k plus with 135 over 2 must be equals to 0. Okay, I move this k to the other side. So 540k over 8 equals to 135 over 2. So k will be, I do cross multiply here. So 135 times 8 over 2 times 4, 540. If we calculate this, we can get 135 times 8 divided by 440. So the k will be 1. So this, for the second part, the k equals to 1. That is for number 2. Now we go to number 3. The equation x squared plus px plus q equals to 0 has the roots minus 3 and 5. Find the values p and q. So for this, it says that it has a root minus 3 and 5. So it means we can try to substitute the minus 3 to the x. So when x equals to minus 3, so it's become minus 3 squared minus 3p plus q equals to 0. And x equals to 5, become 5 squared plus 5p plus q equals to 0. So from here we shall do the simultaneous equation. So we have 9 minus 3p plus q equals to 0. So this is 25 plus 5p plus q equals to 0. We minus it. We use the elimination. So this is minus 16 minus 8p equals to 0. So 8p equals to minus 16, p equals to minus 2. And then we can use one of the equation. I use the first one. So 9 minus 3. I substitute p with minus 2 plus q equals to 0. So 9 plus 6 plus q equals to 0. So 15 plus q equals to 0. So q equals to minus 15. That is for the first part. And for the second part, using these values p and q, find the field constant r with the equation this one has equal roots. So we have x squared minus 2x minus 15 plus r equals to 0. Whenever we talk about the equal roots or maybe distinct roots, that means we talk about discriminant, which the discriminant formula is b squared minus 4ac. Here for this case, it says it has equal roots. So it means the discriminant equals to 0. So we can see that this, we have this equation. The A is equals to 1, B equals to minus 2, and then the C is minus 15 plus R. And then we input the formula, this one B squared minus 4AC equals to 0. So the B is minus 2, is 2 squared minus 4 times the A times C minus 15 plus R equals to 0. So I continue here, so it's 4 plus 60 minus 4R equals to 0. So we have 64 minus 4R equals to 0. So 4R equals to 64. R equals to 16. So that is for number 3.